In this particular problem, we need to show that n plus 1 times sine up to theta equals to n minus 1 times sine up to alpha whenever we have tangent of alpha plus theta equals n times tangent of alpha minus theta. So let us begin. So we'll start the problem with the given condition. So here we are given that tangent of alpha plus theta, so that's equals to n multiplied to tangent of alpha minus theta. So let's divide both sides of the equation with tangent of alpha minus theta. Now we get the ratio tangent of alpha plus theta whole divided by tangent of alpha minus theta. So this will be equals to n. Now what we'll do here, we'll use a method known as the componendo dividendo method. So let's state the definition first. So let's say if we have the ratio a is to b and that's equals to another ratio c is to d, then it implies that a plus b divided by a minus b, that must be equals to c plus d over c minus d. So this is referred to as the componendo dividendo method. So if we apply this, then we have the numerator, which is tangent of alpha plus theta. To it we are going to add the denominator, so that's tangent of alpha minus theta whole divided by, now we'll take the numerator tangent of alpha plus theta, and from it we are subtracting the denominator, so that's tangent of alpha minus theta. Similarly on the right hand side we'll get n over 1, so we'll get n plus 1 divided by n minus 1. Now we will proceed from this step. So we know for a fact that if we have tangent of angle A plus B, so this was given by tangent of angle A plus tangent of angle B whole divided by 1 minus the product tangent of A times tangent of B. Now this can be also expressed as the product. So let's take tangent of A plus tangent of B. This can be also equivalent to tangent of angle A plus B, and to it we'll be multiplying 1 minus tangent of A times tangent of B. Now let's say we started out with tangent of A minus B. Then in that case, we have tangent of A minus tangent of B divided by 1 plus tangent of A times tangent of B. And if we rewrite this, then we're going to get tangent of A minus tangent of B, that will be equals to tangent of A minus B whole multiplied to 1 plus tangent of A times tangent of B. So let's use this. So in the numerator, we have tangent of alpha plus theta plus tangent of alpha minus theta. So let's say we suppose that A is equivalent to alpha plus theta and B is equivalent to alpha minus theta. Then we can immediately find out the value of A plus B. So A plus B, that will be equals to 2 alpha, and A minus B, that must be equals to 2 theta. Fine. So let us begin. So in the numerator portion, we have tangent of A plus tangent of B. Now that means we can rewrite it as tangent of A plus B. So that's 2 alpha multiplied to 1 minus tangent of A. So A means we have alpha plus theta times tangent of B. So that's simply tangent of alpha minus theta whole divided by, next in the denominator we have tangent of A minus tangent of B. Then in that case we have tangent of A minus B. So A minus B will be simply 2 theta whole multiplied to 1. This time we're going to have positive tangent of A, which is alpha plus theta, times tangent of B, which is alpha minus theta. And on the right hand side we keep it intact. We're going to have n plus 1 over n minus 1. Now we have tangent of 2 alpha divided by tangent of 2 theta. So what we'll do, we'll take this particular expression, the remaining factors, which is 1 minus tangent of alpha plus theta times tangent of alpha minus theta present. So what we'll do, we will multiply the numerator as well as the denominator with the factor. So we're going to take cosine of alpha plus theta multiply to it cosine of alpha minus theta. So this is a common factor. We're going to multiply to both the numerator as well as the denominator. So here also in the denominator we're cosine of alpha plus theta times cosine of alpha minus theta. Fine. The reason why we're doing this, the moment we multiply with cosine alpha plus theta times cosine alpha minus theta, then this particular section or this factor will now become cosine alpha plus theta multiplied to cosine alpha minus theta minus, now what's the value of cosine alpha plus theta times cosine alpha minus theta when multiplied to tangent alpha plus theta times tangent alpha minus theta. In some sense, what we're doing is we're multiplying cosine, let's say we take angle A and multiplying it to tangent of angle A. Now we know that the tangent function, that is the ratio of sine over cosine. So the cosine and cosine gets factored out, we are left with only the sine function. Now that means cosine alpha plus theta times tangent alpha plus theta. So that's going to give us sine alpha plus theta. Similarly, cosine alpha minus theta times tangent alpha minus theta is going to give us sine alpha minus theta. So this is done. And similarly in the denominator, we're going to get cosine of alpha plus theta times cosine of alpha minus theta, but we'll have a positive sign here, multiply plus sine alpha plus theta times sine alpha minus theta. Fine. And this entire thing, this will be, so this is the formula part, this will be equals to n plus 1 divided by n minus 1. Now, in the numerator portion, we can observe here that we have something of the form cosine of A times cosine of B minus sine of angle A times sine of angle B. So this is nothing but cosine of angle A plus B. And in the denominator, we have cosine of A times cosine of B plus sine of A times sine of B. So that means we have cosine of A minus B. So here in our case, A, so this is equivalent to alpha plus theta. We have already mentioned it. And B is equivalent to alpha minus theta. So the numerator now becomes tangent of 2 alpha. This will be multiplied to, so we have the form cosine A cosine B minus sine A sine B. So this is nothing but cosine of A plus B. And in the denominator, we have tangent of 2 theta, to which we are multiplying cosine of A cosine of B plus sine of A times sine of B. So that's nothing but cosine of A alpha plus theta minus B. So that will be negative alpha plus theta. And that's equals to n plus 1 over n minus 1. So here in the numerator, we have theta and theta cancelling out, alpha and alpha cancelling out. That means we are now left with tangent of 2 alpha multiplied to cosine of, so alpha plus alpha will be 2 alpha, divided by tangent of 2 theta times cosine of 2 theta. So that's equals to n plus 1 over n minus 1. As we have already mentioned, the product of the tangent and the cosine gives us the sine function. So in the numerator, we get sine 2 alpha, and in the denominator, we get sine 2 theta. So this will be equals to n plus 1 over n minus 1. Let's multiply. So we get n plus 1 times sine theta, sine 2 theta. So that becomes equals to n minus 1 times sine 2 alpha. And this is what we were asked to prove. So let's verify that. We have it. So we finally obtained n plus 1 times sine 2 theta, that equals to n minus 1 times sine 2 alpha.